Hi there everyone. We're going to look at Level 1 Mathematics 2013 graphs paper, and we'll just jump straight into it, I suppose. So if you want to read this question, pause it and read it. I also suggest that you print this out first so that you can follow what you would do and compare that with what I'd do here. So we'll come to our first question here, which is write the equation for the amount Jamie was given by his grandmother in terms of his age n at Christmas. So up the top it said that his grandmother gave him $5 plus $2 for each year of his life. So in other words, it's going up by 2n, where n is the number of years of his life. And he starts out with plus 5. And so the only other thing that we have to put in there is a equals, and that's our answer for question 1. Now in terms of achieve merit excellence, that would be achieved, so you'd expect to see a U in your assessors column. Okay, find the amount that Jamie was given by his grandmother at Christmas when he was 12. So what we're doing there is we're putting 12 into this equation instead of n. So we're writing a equals 2 times 12 plus 5, and then we put that into our calculator, or we work it out in our head, and that comes to $29. Now it's asking for the amount, so we'll just write that with a dollar sign as well to make that clear. Okay, on the grid below, plot the graph that shows the amount of money that Jamie's grandmother had given him for each Christmas. Okay, so when he is 1, he got given $7, so we'll make a little cross there at 7. When he is 2, he got $9. When he is 3, he got $11. And it's going up by 2 each time, so we've gone 7, 9, 11, then actually no, we'll do that again. 7 will be about here, 9, 11, 13, 15, 17, 19, 21, 23, 25. Okay, just be wary there of the scale on the column. As you can see with my first attempt there, I got the scale wrong, so make sure that you're careful with how you read that scale. Okay, on to the next page. Jamie's sister Anna is 3 years younger than him. Each Christmas her grandmother also gave her $5 plus 2 for each year of Anna's life. On the grid, sketch the graph showing the total amount that their grandmother gave them in each Christmas. Now they've bolded this total amount, which means we need to pay careful attention to that. So if she's 3 years younger, then that means that she's going to be getting an amount on her first Christmas, and that's going to be 7. So if we look at her first Christmas, it's going to be when her brother, what's his name again? Jamie. It'll be when Jamie's birthday, or Jamie's 4th Christmas is. So I've got 13 plus 7, so that will be a total of $20. The next year she'll get 9, so I've got 15 plus 9, so that's going to be 24. The next year he's getting 17, and she'll get 11. 17 plus 11 is 28, and we won't be able to fit any more on the graph there. Okay, just I guess one thing here I'll say why I've done points rather than a line is because they're not getting money throughout the year, they're just getting it at Christmas, so it's not a continuous graph. That's why I've got points rather than lines. Okay, this Christmas Jamie and Anna received a total of 44 from their grandmother. Write at least one equation and use this to find out how old Jamie was this Christmas. Okay, so if we think about Jamie's equation, his amount is a equals 2n plus 5, and for the amount for his sister, that's going to be 2n plus 3 plus 5, because she's 3 years younger. So that's going to simplify to 2n plus sorry, that'll be minus 3 because she's younger, minus 3. So that'll be 2n minus 6 plus 5, so that simplifies to 2n minus 1. Okay, now if we collect these two equations, this one's for Jamie and this one's for Anna. If we put these two equations together, so if we sort of add them together, then we're going to have a total amount, or a new equation for amount, which is 4n plus 4. So that's from having 2n plus 2n, which gives us 4n, and plus 5 and minus 1, which gives us 4. And the amount this year is 44. So that gives us an equation 44 equals 4n plus 4. And this is an equation for us to solve. So let's start by subtracting 4 from both sides. I've run out of room here, so I'll bring it up here. So we get 4n equals 40, and divide both sides by 4, and so n equals 10. Okay, so this is the age of Jamie at this point, so I'll just have a just make sure, yep, Jamie. So for this one, Jamie is 10 years, so Jamie is 10 years old. Okay, now in terms of what you're getting for that, if you've got that all correctly written, you're going to get an R in the markers column, which is equivalent to merit. And this one up here, you're looking at R as well. And to get the correct answer up here, you're looking at a U. So only merit questions so far. Alright, this next question here, give the equation to calculate the total amount Jamie's grandmother had given him in n Christmases. So here it's really asking us what the totals add up to. So after one Christmas he gets $7. After 2 Christmases he gets 7 plus 9, which is going to be 16. After 3 Christmases he's going to get 16 plus 11, which is 27, and so on it goes. Now in terms of patterns, our difference between these two is 9, and our difference between these two is 11. We'll go one more so that we can get another difference. So 27 plus 13, that would be 40. So difference here would be 13. So difference is going up by 2 each time. So that's our first difference there, and this is our second difference. And when our second difference is the same, that means we've got a quadratic equation. So that means that we've got something like, where the total is something like an squared plus bn plus c. Alright, now there's lots of different ways to work out quadratic patterns, but the way that I find quite useful is to put 1 in for n. So that would give us n squared plus, that would give us a, because n squared is 1, plus b plus c equals, and the total for the first year is 7. Then we put 2 in for n, and n squared is 4, so we get 4a, and n is 2, so we get 2b plus c, and our next total is 16. And then we put 3 in, 3 squared is 9, so I've got 9a, and 3b and c equals 27. So we've got 3 equations here that we can solve by elimination. So I'm going to go equation C minus equation B. So that gives us 5a plus b equals 11, and then I'm going to go b minus a. That gives me 3a plus b equals 9. Now I'm going to eliminate these two. So 5a minus 3a is 2a, b minus b is 0, and minusing those two we get 2, and so a equals 1. So in our pattern we can write 1n squared for that first part. Now we need to work out b. So I'm going to put this back into my original equation instead of a. So that gives me 3 plus b equals 9. So b equals 6. So I can put 6 into b, 6 in. Now I'll put them both back into our original equation instead of a and b. So I've got 1 plus 6 plus c equals 7. And so c equals 0. So I don't need to write anything to c. And so that's our equation for our total sum. Now, if you get all that, that's T30 extended abstract thinking. Okay, question B, give the equation for the graph below. Okay, we'll start with the intercepts here. So I've got 1 at 0 and 1 at 3. So that means it's going to be y equals something times x minus 3. So I've got to work out what that something is. And so to do that, we're going to pick a point that we can easily read. So it looks here like it passes through 5, 5. So that means that if we put 5 in for y and 5 in for x, I'll call that something a for now. So a times 5 for x and 5 minus 3. So that's 5 equals 5a times 2. 5 equals 10a. Divide both sides by 10. And so a equals a half. So that means that in here we can put a half instead of a. So write a half x, and that gives us our equation, and that's also a t. Alright, and that's question 1. I think we're finished there.